Let's do a sorting algorithm demonstration today. Sorting may seem very mundane, but it is used very often. For example, when Google gives you a traffic routing recommendation, it is calculating tens to hundreds of possible routes and figure out which one is the shortest. So this has to be done on the fly. In other places, it is used for search result placement, ads placement based on revenue for Facebook, Google, and Amazon, and ChatGPT dynamic AI generation. Sorting is very fundamental. Let me show you a demonstration using graphics. Let's say we want to order the size of 5 apples, shown here. First, we introduce some randomness, and the apples are ordered randomly. So how do we put them from the largest to the smallest? The way to approach it is to solve this problem in a way that computers can handle. So first, we compare the first apple size to the next one. If it's bigger, we don't do anything. And then we compare the first apple size to the third one. This one turns out to be smaller than the third one. So we swap out the position between the third and the first. And then we compare the first one to the fourth. It is bigger. And we then compare the first one to the fifth. It is still bigger. So after the first loop, we place the largest apple at the top of this list. Now we repeat the same process. We first compare the size of the first apple to the second one. It is smaller. So we switch the positions of the second and third apple. And now we compare the first one on the list to this one. It is bigger, so we do nothing. And then we compare the second one to the fifth one. It is smaller. Now we swap the position between the second and the fifth. So after loop 2, we're guaranteed that the next largest apple is at the top of the list. Its position is fixed. Now we repeat this process, comparing the first one in the rest of this list to the next one. It's bigger, so we do nothing. And then we compare this to the last one. It is smaller. We swap the position. After the third loop, the third largest apple is at the top of the list, and we fix its position. Final round, we compare this apple to the last one. It is smaller, so we swap their position. After this, we fix the position, and since we have only one left, this position is fixed. The end result is we ordered the size of apples from the largest to the smallest. There are some issues. If the number of apples is large, then the amount of operations can be humongous. The first pass, we compare n, second pass, n minus 1, third pass, n minus 2. So the total number of operations is n times n minus 1 divided by 2. For example, if n is 5, then the total number of operations is 10. This can be quite daunting if you have many routes, combination possibilities to compare. Now we know how to do this. It is still another matter to put it into codes. We're going to use a list and use a nested loop. First, let's create an arbitrary list. This list contains 7 numbers, 1, 2, 3, 4, 5, 7, and 17. So those 7 numbers needs to be sorted from the largest to the smallest. We first print this to verify. So this is a list. There is a variable called len list. This shows the length of this list. The length, because it has 7 items, the length should be 7. We can access any number in the list. For example, list 1 gives you 2. This is this position. The algorithm goes like this. We first set the outer loop count I equal to 0, and we set the inner loop count j equal to 1. The outer loop goes like this. While I is less than the length of the list, we repeat. Inside the outer loop, there's an inner loop. The inner loop goes like this. For j in range of I to length of list, we compare. If the list at position I for the inner loop is less than the list at position j, we're going to swap them. The swapping is done using these three lines. First, we allow a temporary register to be equal to the list of I. Then we let I equal to the position at j. And then we let the position at j equal to the temp. These three lines finish the swapping. After the swapping, we increase the number of j by 1, so we count the next apple. This is the inner loop. At the end of the inner loop, we let I increment by 1, and this goes back to the outer loop. Let's look at the results. After the result, you can see the numbers are swapped from the largest to the smallest. Now, you may want to know exactly how this runs. So let's add a tracker. At the end of every inner loop, we print the list, but we also add some notation for ourselves. So this is outer loop number I list. Oop, there's a mistake. Typo, print. So now we have the result. After the first outer loop run, 17 is moved to the largest. After the second outer loop run, 7, 4, 5, 6. This is not very exciting because this is already done after the first loop. So let's throw in some numbers in the list. And let's say our list, instead of being 1, 2, 3, 4, 5, 7, 17, let's put a big number up front, 344. And let's put another big number, 8. So now, the list has 9 numbers. And let's run it. You can see after the first loop, 344 is moved to the first position. After the second loop, the next largest, which is 17, is moved into the second position. After the third loop, the one that's next, which is 8, is moved into the third position. After the next loop, the next number up, 7, is moved into the fourth position. 5, 4, 3, 2, 1, and so on, until the sorting is completely finished. Well, I hope you like it. Now, this is original list 1, 2, 3, 4, 4, 3, 4, 8, 5, 7, 17. And this is a code, and this is the result. Let's break down the steps a little bit further. Initially, this is a list, and this is list position 0, 1, 2, and so on. On the first loop, I is equal to 0, and j goes from 0 to the length. And we first compare this 1 with 2. 2 is bigger, so we invoke this position swap, and 2 is moved to the position of 1. That's why later on the 1 is at the second location. And after this, we compare 2 to 344. 344 is bigger, and we swap 344 and 2. That's why 344 now comes to the first position, and 2 is at the third position. Now we compare 344 to 3. It's bigger, then we don't do any swap, and so the rest of it is never swapped. 3, 4, 8, 5, 7, 17. retains its position. 1 is here and 2 is here. And now we do I is equal to 1. This is the second outer loop. For the second outer loop, 344 is fixed. We compare 1 to 2 again, and we swap 1 and 2. So now 1 is at this position. Now 2 is compared to 3, and 3 swapped. 3 is compared to 4, and 4 is swapped. And so on, so forth. 8 is bigger than 4 and is swapped. That's why 4 is here and 8 is here, but 8 is then compared to 5, 8 is then compared to 7, and 8 is then compared to 17. We swap 17 and 8. So now 344 and 17 are fixed and 8 is at the end. Now we go to the next swap location. I is equal to 2 right now. We compare 1 to 2, and 1 is swapped to here. And we compare 2 to 3, and 2 is swapped to here, and so on and so forth. You know the drill now. And at the end, 8 comes up to top, and the next largest, 7, is left at the end.